Hello guys, welcome to another one of my video presentation for the subject fluid machineries or machinery. So this is actually the second part of my discussion regarding sa tinutukoy natin total dynamic head or TDH. So ito yung parameter or variable that is actually used for the proper sizing of the so-called centrifugal pumps. So mag-try tayong mag-solve ng mga problems natin. So I have prepared at least 7 problems. So for problem number 1, the suction pressure of a pump reads 2 inches of mercury vacuum and then the discharge pressure reads 130 psi. So this pump is used to deliver 100 gallon per minute of water with a specific volume of 0.0163 cubic feet per pound of mass. So ang requirement dito is for us to be able to determine the pump work. So apat yung choices, 4,600 watts, 5,700 watts, 7,400 watts, tapos 8,400 watts. So, tinatin para merong confusion. Anong confusion? So, yung mga choices kasi natin dito, all expressed in terms of the watts. However, ang requirement is in terms of the pump work. So, pag sinabi kasi natin pump work, wala siyang time factor involved. Pag sinabi naman natin watts, watts is a unit of power which is actually described as the rate of doing work or meron siyang tinatawag na work per unit time. So, meaning, ang hinanap natin dito is not just the so-called pump work, rather, ang hinanap natin dito is yung tinutukoy nating pump work per unit time. So, first thing that we have to do is to properly list down the given conditions. So, list down natin siya. So, given, so, 2 inches of mercury, vacuum. So, P1, you have 2 inches of mercury, tapos lagay ko dito is vacuum. Then, for P2, so for P2, nakalagay is 130 psi. By the way, since yung P1 natin is vacuum, pag sinabi natin vacuum, negative pressure siya. So, yung P1 natin, hindi siya positive P1, rather negative P1. So, magbabago yung formula natin in the end. So, ano pa ibang given conditions natin? 100 gallons per minute of water, gallon per minute, gallon unit of volume, minute unit of time. So, volume per unit time is described as volume flow rate. So, B, meron dot sa taas. So, ang hinahandle niyang fluid is water. So, volume flow rate ng water is 100 gallon per minute. So, ayan. So, other given conditions, ang specific volume daw ng water natin, is you have 0.0163 cubic feet per pound of mass. Ayan. So, para mas maintindihan natin yung hinahanap dito sa ating problem statement, maglalagay tayo dito o gagawa tayo ng diagram or illustration representing that of a pump. So, ayan. So, drawing tayo ng pump. Ayan. So, let's see for example, itong rectangle na to, ito yung tinutukoy nating pump. So, ito yung pump. So, may papasok, meron lalabas. So, in, tapos you have out. So, yung papasok sa kanya, yung tinutukoy nating brake power. Then, yung lalabas sa kanya is yung tinutukoy nating water power. So, in this case, yung brake power sa water power, para sila magkaiba. Mas mataas yung water power, mas mababa yung brake power. So, mas mababa palaging output over sa tinutukoy nating input, always due to the presence of what we call losses. Kaya wala tayong tinatawag na efficiency that is equivalent to 100%. Ayan. So, hinanap natin is pump work. So, pump work daw. So, titignan natin. Ang pump work natin dito is the so-called water power. So, base sa diagram, ang hanapin natin dito is yung tinutukoy nating water power. So, pump work is equivalent to what we call the so-called water power. Yan. So, yung formula naman natin ng water power, we have gamma ng water o gamma ng fluid. So, in this case, ang hinahandle natin ng pump is actually water. So, instead na gamma ng fluid, specify natin properly. So, gamma ng water, volume ng fluid or volume ng water, tapos yung tinutukoy nating total dynamic head. So, ayan. So, tingnan natin. So, total dynamic head. So, lagay muna natin dito is where yung tinutukoy natin total dynamic head is actually composed of the following. So, pressure head. So, P2 minus P1 all over gamma ng fluid. So, in this case, gamma ng water plus yung velocity head. So, B2 square minus B1 square all over 2 observed gravity plus yung elevation head, you have Z2 minus Z1 plus yung frictional losses magmula sa point of intake sa point of discharge. So, HF1 and 2. So, kung titignan natin yung given conditions, ito, no? Sa mga given conditions natin, walang frictional losses, wala ding elevation head sa point of entry sa point of discharge, at wala din naman mga corresponding speeds. So in this case, ang mangyayari is tatanggalin natin yung mga wala. So velocity head, elevation head, tapos frictional losses. So in this case, ang formula natin ng pump work, so sulat ko na lang, ano? So yung pump work natin, eventually ang formula natin then becomes what? Gamma ng water, volume flow rate ng water, then yung tinutukoy nating total dynamic head. So, ang formula natin ng total dynamic head, palitan natin, gamma ng H2O, volume flow rate ng water, tapos yung panibagong formula natin ng total dynamic head, you have P2 minus negative P1 all over gamma ng water. So, negative P1 kasi nga, ang value natin dito ng P1, meron statement na siya is actually in vacuum. So, ibig sabihin, kung yung P1 natin, palagi siya in terms of vacuum, yung P1 natin then becomes negative. Pero kung wala naman mention na yung P1 natin is expressed in terms of vacuum, yung P1 natin is labeled as positive. So in this case, ang mangyari natin dito is yung P2 minus negative P1 magiging P2 plus P1. So, cancel muna natin yung mga wala. So, gamma ng water, gamma ng water. So, in the end, ang magiging formula natin is actually ito na lang. Volume flow rate ng water. Then, you have P2 plus P1. Ayan. So, titignan natin, i-add natin dalawang pressure values. However, ang problema natin, base sa given conditions, yung P2 is in terms of PSI, yung P1 naman in terms of inches of mercury. Although, para silang units of pressure, hindi sila po pwedeng combine. So, in this case, kinakailangan gagamit tayo ng common unit. So, in this case, i-retain natin PSI kasi hindi natin pwede i-cancel out yung inches of mercury pagdating dito sa volume flow rate ng water para matain natin yung unit ng watts. So, gagamit tayong conversion, convert natin yung P1, inches of mercury vacuum. So, meron tayong tinatawag na standard reference for atmospheric or barometric. So, ano yun? So, kung kukuha tayo ng sample ng hangin sa atmosphere, yung hangin na yon, ang value niya is 14.696 PSI. Tapos, katumbas ng value is you have 29.92 inches of mercury. So, in this case, magkakancel out yung inches of mercury. So, in the end, ang matitira dito is in terms of the PSI. So, ang value niya is, once computed, ang value niya is equivalent to 0.9823 PSI. So, ayan. So, lagay na natin yung mga corresponding values natin dito. So, pump work natin, you have what? Volume flow rate ng water, you have 100 gallon per minute. So, 100 gallon per minute. Then you have 130 plus 0.9823. 0.9823 in units of the PSI. So pag sinabi natin PSI, you have pounds per square inch. So ayan. So tingnan natin kung ano yung matin natin yung unit. So in this case, ang mangyayari is actually ito. So kinakailangan mag-provide tayong conversion. Ano yung conversion na gagamitin natin? So ang gagamitin natin conversion is actually ganito. So convert natin yung gallon in terms of the cubic feet. So for every 1 cubic feet, meron tayong 7.481 gallon. And then kung titingnan natin, gallon. So far, ang goal natin is mawala si square inches. So in that case, po-provide ang conversion once again. For every 12 inches, you have what? 1 feet. So yung power dito sa square inch o sa inch is square. Distribute tayo ng power of 2, power of 2, power of 2. So mawala si square inch. So si cubic feet, mababawasan, mawala si square feet. So matitira dito is feet pound per minute. So meron tayong conversion na for every 1 horsepower, meron tayong 33,000 feet pound per minute. So gawin natin siya. So provide pa tayo ng another conversion dito. Yan. So you have what? 33,000 feet pound per minute per 1 horsepower. So check natin. So you have here pound, minute, feet pound per minute. So matitira is horsepower. However, basic sa choices natin, hindi horsepower, rather in terms of the watts. So provide tayong conversion once again. So for every 1 kilowatt, we have 1.34 horsepower, or for every 1,000 watts, we have what? 1.34 horsepower. So in this case, ang mangyayari is magka-cancel out si horsepower. Ang final unit natin is expressed in terms of the watts. So in this case, nakuha na natin yung hinahanap natin, which is yung tinutukoy nating pump work. So pump work, and or the so-called water power is equivalent to 5,701.6 watts, or technically this is equivalent to what? 5,700 watts. So meaning so pump work natin is 5,701.6 watts, or almost equivalent to 5,700 watts. So yung choice natin dito is actually what? B. So ang answer natin dito is B. Ayan. So yung choice natin is B. Ayan. So ang sagot natin is 5,701.6 watts or 5,700 watts. So lilabel ko lang properly. Ayan. 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 So yung choice natin is B. So ito yung solution natin for this particular problem, which is problem number 1. So problem number 2 naman tayo, So problem number 2. What power is used to drive a boiler feed water pump delivering a mass of 35 kg of mass per second at a head of 500 meters? So tingnan natin nandito. So list down natin yung mga given conditions natin properly. So given siya, no? So, sabi, mass, pero yung unit niya, meron siyang unit time. So, although hindi appropriate yung term na ginamit dito, ang value natin dito, yung number, yung given condition natin dito, is what we call the so-called mass flow rate, or mass pa rin siya, pero meron siyang time factor. So, mass flow rate natin, you have 35 kilogram of mass per seconds. Ayan. So, tingnan natin, no? So, 35 kg mass per second. Tapos, ang head niya, 500 meters. So, yung head na tinutukoy dito is what we call the so-called total dynamic head. So, TDH, you have 500 meters. Ayan. So, check muna natin. Ano masabi natin dito? So, what power is used to drive a boiler feed water pump delivering a mass of 35 kg mass per second at a head of 500 meters? So, check natin. Power daw. So, kung walang specification as to what kind of power yung hinahanap natin, ang hanapin natin dito is yung tinutukoy nating water power. So, ulitin ko ulit. Kung walang specifics o specific na requirement as to what kind of power yung hinahanap at power ang pinapahanap, ang hanapin nyo dito is yung tinutukoy nating water power. So, sulat ko water power. So, water power, WP, again, ang formula natin is you have gamma ng fluid. Again, ang gamma ng fluid natin dito is gamma ng water, volume flow rate ng water, again, total dynamic head. So, ito yung formula. So, titingnan natin yung mga given conditions base dito sa formula. Ang meron lang tayo dito is yung total dynamic head. Tapos, wala tayong gamma ng water, wala rin tayong volume flow rate ng water. Pero, tingnan natin kung ano meron, no? Anong point ko? So, tingnan natin to. Gamma ng water. So, gamma ng water, so gamma is described as the ratio between weight per unit volume. Yan. Or, isa pang possible formula is actually ganito. Pwede siya maging weight flow rate all over volume flow rate. So, ano meron dito? So, ang weight flow rate kasi is weight per unit time. Tapos, pag sinabi naman natin volume flow rate, you have volume per unit time. So, ibig sabihin, sa oras na meron tayo, meron lumalabas. Yung lumalabas na yun, meron siyang certain weight. And then, yung lumalabas na yun, meron din siyang certain volume. So, ibig sabihin, para sa time factor na involved, pwede i-cancel out yung time. So, in this case, lumalabas, ang formula natin ng gamma ng water, other than weight per unit volume, pwede rin pala siyang weight flow rate all over volume flow rate. So, check natin. Ano ba pinagkaiba ng weight flow rate dito sa mass flow rate? So, weight flow rate is weight per unit time. Ang mass flow rate naman is mass per unit time. So, ibig sabihin, kung wala namang pagbabago sa gravity, pwede din man natin sabihin na yung mass flow rate saka weight flow rate is considered to be technically the same. So, check natin. So, lagay ko muna yung sinabi ko kanina. So, ang ilalagay ko lang dito is actually ganito. Where since no gravity is given, yung value ng mass sa value ng weight is equal, or yung mass flow rate saka yung weight flow rate parehas. Equal lang daw siya. So, ang point ko lamang dito is actually ganito. So, kung wala daw given na gravity, yung value ng mass, value ng weight, parehas, value ng mass flow rate, saka weight flow rate, parehas din sila. So, ang point ko lamang is actually ganito. So, kung kilogram of mass, kung meron tayong say 1 kilogram of mass, equivalent siya sa 1 kilogram of force. Tapos kung meron tayong 1 kilogram of mass per second, equivalent siya sa 1 kilogram of force per second. So ito lang. So ibig sabihin is kung wala daw given na gravity, re-retain natin yung number, tapos yung corresponding unit, medyo babaguhin lang natin ang bahagya. Ayan. So ang point ko lang is actually ganito. So therefore, yung 35 kilogram of mass is equivalent to 35 kilogram of force. So check natin kung tama. So to prove, lagyan lang natin, to prove. To prove. So weight flow rate, ito yung formula ng weight flow rate. Weight flow rate is mass flow rate, gravity all over yung gravitational constant. So ang mass flow rate natin, you have what? 35 kilogram of mass per second. Observe gravity, kung wala nang given, magre-refer tayo sa standard. Ang standard natin is you have 9.806 meters per second square. Ang gravitational constant na gagamitin natin, pwedeng tatlong pagpilian. So, pwedeng 1, pwedeng 32.174, or pwede ding 9.806. So, for compatibility purposes, ang gagamitin ko is 9.806. So, dapat fully aware ko din sa mga corresponding unit. Ang unit niya is kilogram of mass, meter, kilogram of force, square, seconds. So, ito natin magka-cancel out. So, magka-cancel out si meter per second square, kilogram of mass, 9.806, 9.806. So, matitira is 35. So, gaya ng sabi ko sa inyo, lumalabas, i-retain lang natin number, babaguhin lang natin, tweak lang natin bahagya yung corresponding unit. So, from kilogram of mass, magiging kilogram of force, or from pound of mass, magiging pound of force. So, technically speaking, lumalabas na yung weight flow rate natin dito is 35 kilogram of force per seconds. Ayan. So, sunod na natin. So, since meron tayong weight flow rate, so check natin, no? So, balikan natin to. So, kung titingnan natin to, no? Kung titingnan natin yung formula, sabi, gamma ng water, volume flow rate ng water. So, base sa formula nito, pagka yung gamma ng water, kinumbay natin din sa volume flow rate ng water, lumalabas weight flow rate. So, ang point ko lamang dito is actually ganito. Lumalabas na yung tinutukoy natin water power. Therefore, water power is equivalent to, ulitin ko na yung formula, gamma ng water, volume flow rate ng water, tapos total dynamic head. So, base dun sa pinakita ko sa inyo kaninang formula, yung kung i-reverse natin, so swap natin ng places yung gamma ng water sa volume flow rate. Ang formula ngayon ng volume flow rate saka ang formula ngayon ng volume flow rate is ito. Tingnan natin ulit no. So, kung i-combine natin volume flow rate saka gamma ng water, which is technically itong dalawang to, equivalent value niya is weight flow rate. So, technically speaking, ito pala ang dalawang variables sa to. Pag kinombine, ang tawag sa kanila is weight flow rate ng water multiplied by the so-called total dynamic head. So, check natin, no? So, lumalabas na, so, ulit ko, so water power, WP, is equivalent to weight flow rate ng water. Ang weight flow rate ng water natin, again, is 35 kg force per second. So, you have here what? 35 kg of force per second. Tapos, ang total dynamic head, base dito sa problem statement natin, is 500 meters. 500 meters. So, check natin. So, power is described as the rate of doing work. Pag sinabi natin work, meron tayong i-displace na weight. So, pag sinabi natin i-displace na weight, weight multiplied by distance. So, ito yung unit ng weight. Ito yung unit ng distance out of a given unit of time. So, kilogram of force meter per second is considered to be the so-called water power. However, wala siyang identity. So, tingnan natin. Base dito sa mga choices natin, ang listed choices natin are all expressed in units of the kilowatt. So, pag sinabi natin kilowatt, ulit lang natin dito, no? Pag sinabi natin kilowatt, kilowatt is kilojoule per second. Or, ang kilojoule naman is you have kilonewton meter. So, in this case, puprovide na lang tayo ng conversion. Ano yung puprovide natin conversion? That for every 9.806 Newton, meron tayong 1 kilogram of force. So, ayan. So, kakancel out ngayon sino? Kilogram force, kilogram force. So, si Newton, gagawin lang nating kilonewton. That for every 1 kilonewton, meron tayong 1,000 Newton. So, Newton. So, you have what? Kilonewton meter. Kilonewton meter is kilojoule. So, kilojoule per second is a unit of the so-called kilowatts. So, in this case, lumalabas na ang water power natin so, sulat ko na siya. Water power, WP, therefore is equivalent to 171.605 kilowatts or almost equivalent to, sa mga choices natin, ang pinakamalapit is 171.67 kilowatt. 171.67 kilowatt. So, ang choice natin is actually D. Ayan. So, ang final answer natin is you have D, 171.67 kilowatts. So, yan na lang natin. Guguhitan lang natin yung ating final answer. Yan. Ito na siya. So, ito yung problem number 2. So, ayan. So, problem number 3 na tayo. So, a pump is driven by an electric motor, moves 25 gallons per minute of water from a reservoir requiring a total head of 245 feet. The efficiency of the pump and then motor are 64% and then 84% respectively. What size of motor is required? So, para mas maintindihan yung problem, so gumawa tayo dito ng illustration or diagram. So, meron tayo dito ng driver, ito yung driven. So, yung driver natin is what we call the electric motor. Ito naman yung driven, which is what we call the centrifugal pump or pump. So, may papasok, meron lalabas. So, again, yung output is not equivalent to sa input because of the presence of what we call losses. So, yun din yung reason kung bakit meron tayong efficiency at the efficiency na yun is less than 100%. So, kung meron tayong 64% efficiency on the part of the pump, meaning 36% are considered to be losses. Kung meron tayong 84% efficiency on the part of the motor, meaning meron tayong 16% na losses on the part of the motor. So, base dito sa dalawang numbers na malabas, mas minimal yung losses natin that could be found on the part of the motor as compared to sa losses that could be found on the pump. So, ayan. So, to begin with, so pag kami pumasok doon sa mismo pinaka-electric motor, ang tawag natin dito is what we call the motor size. Tapos, ang lalabas sa kanya is what we call the brake power. So, yung lalabas doon sa electric motor, yun yung mismong magpa-power up doon sa pump. So, yung lumabas sa kanya, yun naman yung papasok sa kanya. So, yung input ng pinaka-pump is still what we call the so-called brake power. And then, once again, dahil sa presence ng losses, yung brake power, hindi na siya brake power. Rather ang tawag natin doon is what we call the water power. So, ayan. Water power. So, list down na natin properly mga given conditions. So, first one, ang given natin, 25 gallon per minute of water. Gallon, unit of volume. Minute, unit of time. So, volume per unit time is what we call the volume flow rate. So, volume flow rate, from 1 to 2, constant lang yan. So, lalagay ko lang siya as volume flow rate ng water. So, you have 25 gallon per minute. Tapos, ang total head doon niya, TDH is you have 245 feet. Yan. Tapos, ang efficiency, so ito yung formula ang gagamitin natin, parang N na medyo malandi or medyo maarte. Tapos, N ng pump is 64%. Tapos, yung N or efficiency naman on the part of the motor is 84%. Ayan. So, ang hinanap dito is what size of the motor is actually required. So, sulit natin. So, check na natin. So, ganito gagawin natin. So, ang hinahanap natin is what size of the motor. So, dito tayo sa may motor. So, sa may motor tayo, no? So, motor efficiency. Ang motor efficiency, basically ang formula natin ng efficiency is output all over input. So, base dito, ang lumabas is brake power or BP. Tapos, ang pumasok is yung tinutukoy natin motor size. Motor size. Ayan. So, in this case, na malabas, ang formula natin ng motor size, therefore, is ito. Motor size is equivalent to brake power all over the motor efficiency. So, ayan. Diba? Then, ang problema natin dito is ganito. For us to be able to solve for the value of the motor size, kailangan natin ng brake power other than yung motor efficiency which is already given. So, lumalabas, kinakailangan hanapin natin yung brake power. Saan pa ba may brake power dito? So, titignan natin, yung brake power na output dito on the part of the electric motor is used to drive yung tinutukoy nating pump. So, in this case, gamitin naman natin isang data pagdating sa pump. Ang data natin pagdating sa pump is yung pump efficiency. So, sulit natin. Pump efficiency. Yan. So, again, output all over input. So, kung titingnan natin yung diagram, ang output natin is the so-called water power. At mismong input natin is yung tinutukoy nating brake power. Ayan. So, meaning, ganito ang mangyayari dito. Drive natin yung formula ng brake power. So, brake power is equivalent to what? Water power all over yung tinutukoy nating pump efficiency. So, in this case, ang mangyayari ngayon dito is actually ganito. Therefore, ang motor size natin is brake power. Ang formula natin ng brake power is you have what? So, brake power is water power all over pump efficiency. So, rekta na natin dito, motor size. Motor size is brake power. Ang panibagong formula natin, water power is water power all over pump efficiency. Tapos, huwag kakaligtaan yung motor efficiency. Ayan. So, para ma-solve natin yung value ngayon na motor size that is used to drive this centrifugal pump, kailangan natin ng water power all over yung pump efficiency as well as yung motor efficiency. So, okay ko, no? Motor size therefore is equivalent to water power. Water power natin is you have gamma ng water, volume flow rate ng water, tapos total dynamic head all over pump efficiency, tapos you have motor efficiency. So, ayan. So, sagutin na natin. So, ang gamma ng water natin, gamma ng water na gagamitin natin. So, titignan natin dito, no? Walang given na gamma ng water. So, in this case, ang gagamitin natin is yung standard value. Kasi wala naman tayo dito ang given condition kung saan pwede natin pagkuhanan ng unit weight or gamma ng water. So, ang ginagamit natin previously is 9.806 kilonewton per cubic meter, or po pwede din siyang 1,000 kg force per cubic meter, or sa English po pwede din naman siya is 62.427 pound of force per cubic feet. Tapos, ang volume flow rate natin, base dito, no? Ang volume flow rate natin is 25 gallon per minute. So, sulat ko, 25 gallon per minute. Tapos, total dynamic head natin is 245 feet. 245 feet. Ayan. So, all over what? All over pump efficiency. Ang pump efficiency is 0.64. Then, motor efficiency is 0.84. Ayan. So, check natin kung ano yung magka-cancel out. So, lumalabas, ang dapat nating unit is expressed in terms of the horsepower. Pero kung pagbabase natin sa 4 unit natin, ang unit natin dito is you have pound force, gallon, feet, all over cubic feet, tapos minute. So, kinakailangan may cancel out. So, ang cubic feet is unit of volume, ang gallon is unit of volume. So, denominator, numerator, so there's a possibility na mag-cancel out. So, supposedly mag-cancel out si gallon saka si cubic feet. Ang matitira natin is you have feet, pound force per minute. Kung saan meron tayong conversion na for every 33,000 feet pound force per minute, meron tayong 1 horsepower. So, provide tayong conversion. So, paano yung conversion natin? So, mangyayari natin actually ganito. For every 1 cubic feet, meron tayong 7.481 gallon. Yan. So, in this case, magka-cancel out si cubic feet, magka-cancel si gallon, cubic feet. So far, you have feet, pound force per minute. And then, gaya sinabi ko sa inyo, for every 33,000 feet, pound of force per minute, meron tayong 1 horsepower. So, gawin natin yan. So, ang mangyayari is, for every 33,000 feet, pound of force per minute, meron tayong 1 horsepower. Ayan. So, mangyayari niyan is magka-cancel out si pound of force, feet, minute, saka minute. So, ang final unit natin dito is expressed in terms of the horsepower. So, pakita natin. So, mangyayari, no? Once properly tabulated, pamagitan ng ating calculator, ang motor size natin is 1 Ang motor size natin is 2.88 horsepower. So, putitin na natin, ang choices natin is 5, 3, 4, saka 7.5. So, yung nearest natin is 3. However, kung titignan natin, what size of motor is required? So, since ang na-compute natin is 2.88 horsepower, pwede tayong gumamit ng 3. Pwede tayong gumamit ng 5. Pwede tayong gumamit ng 4. Pwede tayong gumamit ng 7.5. Yung nga lang, mas sakto o mas reliable na gumamit tayo ng 3 horsepower kasi lumalabas yung iba, mas mataas ang bahagya. So, mas mataas yung rating ng electric motor natin, mas mataas yung value niya. So, in this case, the size of motor that is required to drive this pump is equivalent to 3 horsepower. So, equivalent to 3 horsepower. So, therefore, ang choice natin is actually B. Ayan. So, buhitan ulit natin. Ayan na. So, yung final answer natin dito is 3 horsepower. On choice natin is letter B. Ayan. So, ito yung problem number 3. So, sunodin natin si problem number 4. So, problem number 4, no? Basahin ko. A pump is to deliver 150 gallon per minute of water at a head of 120 meters. If this pump has an efficiency of 70%, what is the horsepower rating of the motor that is required to drive this pump? So, apat again yung choices natin. So, ang requirement is what is the horsepower rating of the motor that is required to drive the pump? Or, in this case, ang hinanap natin once again is yung tinutukoy nating motor size. So, again, kung ito yung diagram natin, motor side, pump side. So, yung papasok, ito again yung tinutukoy nating motor size. So, yung output niya is yung tinutukoy nating brake power. So, yung output dito on the part of the electric motor, yun naman din magsisilbing input on the part of the pump. So, label natin to as the so-called brake power. Tapos, yung output niya is what we call the so-called water power. So, water power. Ayan. So, list down natin properly yung mga given conditions natin. So, lagay natin given. Ano yung mga given conditions natin? So, deliver 150 gallon per minute of water. GPM, gallon, volume, minute, unit of time, volume per unit time is what we call the volume flow rate. So, again, the volume flow rate is constant para do sa suction or para do sa intake or as well as in discharge or B1 saka B2. So, in this case, volume flow rate at 1 and 2 is said to be the same. So, yung volume flow rate natin ng water is 150 gallon per minute. So, gallon per minute. So, yan. So, other given conditions, ang head, o yung tinutukoy natin total dynamic head, you have 120 meters. So, pump efficiency naman niya is at 70%. So, ayan. Ang hinahanap natin dito is what is the horsepower rating of the motor that is required to drive the pump. So, to drive the pump, so kinakailangan natin dito is motor size. So, lagay natin motor size is actually in question. So, ito yung pinaka-motor. So, motor efficiency is output all over input. So, technically speaking, lumalabas ang output natin is what we call the brake power all over the motor size. Ayan. So, in this case, ang problem natin dito is for us to be able to determine the so-called motor size, kinakailangan natin ng motor efficiency as well as yung brake power. So, in this case, tingnan natin. Balik tayo dito. Ito yung motor. So, technically speaking, kung ano yung lumalabas sa motor, hindi naman yun yung papasok doon. Kung ano yung pumapasok doon sa motor, yun yung papasok doon sa, kung ano yung lumalabas sa motor, yun yung pumapasok doon sa may side ng mismong pinaka-pump itself. However, kung titingnan natin yung mga given conditions natin, medyo kulang. So, lagyan natin ng condition. So, in the absence of motor efficiency and in the absence of motor efficiency, so lagyan lang natin condition. In the absence of motor efficiency, it is impossible to obtain. It is impossible to obtain the motor size. Ayan. Pero kung titingnan natin ngayon dito, para makuha natin yung motor size, kailangan natin ng motor efficiency as well as yung brake power. So, ano meron sa brake power? Yung brake power na makikita natin dito on the part of the electric motor, yun din mismo yung brake power na makikita natin na mismo pumapasok dito on the part of the pump na siya naman lumalabas on the part of the electric motor. So, complete natin statement. In the absence of the so-called motor efficiency, NM, it is impossible to obtain the motor size. Thus, consider the brake power BP as the motor size. Ayan, statement natin. So, ulitin ko ulit. In the absence of the motor efficiency NM, it is impossible to obtain the motor size. Thus, let us consider that the brake power BP as the motor size. So, lumalabas possible yon. Supposedly, there is 100% efficiency on the part of the electric motor, which is technically quite impossible for it to take place kasi nga there's no such thing as 100% efficiency. So, yun lang gawin natin, no? Tapos hanap tayo na mas malapit-lapit na value dito sa mga choices natin. So, ang mangyayari ngayon dyan is actually yun to. So, pump efficiency, you have output all over input. So, ano yung lumalabas doon sa mismong pinaka-pump? Ang lumalabas sa pump natin, yung tinutukoy nating water power. Ang pumapasok is yung tinutukoy nating brake power. So, in this case, lumalabas, ang brake power natin is you have the so-called water power all over the pump efficiency. So, ayan. So, lagyan na natin, motor size is the so-called brake power, which is equivalent to the water power all over the pump efficiency. So, sagutin na natin. Yan. So, water power natin, ang formula ng water power natin, again, is you have what? Gamma ng fluid. So, again, water yung hinahandle niya. So, gamma ng water once again. Volume flow rate ng water. Tapos, total dynamic head. All over the pump efficiency. So, ito yung gagamitin nating formula for us to be able to solve for the value of the motor size, which we consider as the value of the brake power. So, gamma ng water. So, gamma ng water, tatlo yung constant natin. So, posibleng hindi given. Pwede tayo mag-refer sa standard value. So, pwede siyang 1,000. Pwede siyang 9.806. So, pwede siyang 62.427. So, since ang pinapahanap sa atin dito is horsepower, which is in English units of measurement, ang gagamitin natin ditong unit weight ng water is yung English value niya, which is 62.427 pound of force per cubic feet. Tapos, ang volume flow rate ng water natin is you have 150 gallon per minute. Tapos, total dynamic head naman natin is 120 meters. 120 meters. Ayan. All over what? All over the cited pump efficiency. Ang cited pump efficiency natin is 70% or 0.7. Ayan. So, provide tayong conversion, no? So, ang gallon sa cubic feet, kinakailangan mag-cancel each other out kasi pare sila yung unit ng volume. So, again, for every 1 cubic feet, you have 7.481 gallon. So, magka-cancel out si cubic feet, gallon, tapos gallon. So far, unit natin is meter, pound, force, minute. So, yung meter, unit siya ng distance pagdating sa SI or metric. So, convert natin yung meter in terms of the feet value. So, lumalabas, for every 1 meter, you have 3.28 feet. Ayan. So, kakancel out si meter, feet. Hindi. Matitira si feet, pound, force per minute. So, meron tayong 33,000 feet-pound of force per minute for every 1 horsepower. So, you have 33,000 feet-pound of force per minute per 1 horsepower. Malabas, feet saka feet magkakancel out. Pound of force saka pound of force magkakancel out. Minute saka minute magka-cancel out. So, final unit natin dito is expressed in terms of the horse power. So, in this case, once properly tabulated or computed, lumalabas na yung value natin dito ng motor size is equivalent to what? So, sagutin natin siya. So, lumalabas na yung motor size natin once properly computed or tabulated is equivalent to 21.33 horsepower. So, pero ba siyang kamukha? So, ayan, meron. So, choice natin is letter D. So, choice natin dito is letter D. Ayan. Ayan. So, tapos na tayo sa 4 problems. Sunodin natin yung problem number 5. So, number 5, a certain pump is used to deliver 150 gallon per minute of water having a relative density of 0.9803. This action and then discharge gauge pressure reads 4 inches of mercury vacuum and then 25 psi respectively. The discharge is 2 feet from the pump center line. What is the motor output if the pump efficiency is 75%? So, tingnan natin nandito. So, first thing that you have to do is, again, list down yung mga given conditions. So, given 150 gallon per minute of water. So, gallon unit of volume, minute unit of time, volume per unit time, we have volume flow rate. So, ang volume flow rate, once again, is said to be constant pagdating sa pumps as well as fans and then blowers. So, volume flow rate ng water, you have 150 gallon per minute. In this case, may bago tayong condition. Ang bago nating condition is yung specific gravity, otherwise known as the relative density, is 0.9803. So, lagay ko, relative density, otherwise known as the so-called specific gravity ng water natin, is at 0.9803. So, ito dapat yung tandaan. Pagka specific gravity natin ng water is no longer equivalent sa value ng 1, hindi na standard. So, gamitin natin yung value ng relative density na to for us to be able to solve for the value of the unit weight. So, apat yung formula ng specific gravity. Ano yung apat na formula? So, specific gravity ng water, you have what? Pwede siyang formula is density ng substance all over density ng water. Pwede din naman na gamma ng substance all over gamma ng water. Pwede din naman yung formula niya is mass ng substance, mass ng water. The last one, pwedeng weight ng substance all over weight ng water. So, ayan. So, in extreme cases, pwede natin gamitin itong formula nito. Mass ng substance all over mass ng water, or weight ng substance all over weight ng water. So, in this case, extreme case lang gagamitin itong dalawang formula nito. So, gamitin natin itong dalawang formula nito. Formula specific gravity in terms of rho, o formula specific gravity in terms of gamma. So, ang gagamitin natin formula ngayon dito is yung formula na ito. So, basically, lumalabas na yung specific gravity ng water is equivalent to specific gravity ng unknown substance is gamma ng unknown substance all over gamma ng water. Standard value ng gamma ng water. Or in specific gravity ng water, ulitin ko ulit, is equivalent to gamma ng substance, yung substance na to being water, tapos gamma ng water na standard value. So in this case, ang formula natin is gamma ng water all over gamma ng water na standard value. So, ano yung standard value nito? So, ang gagamitin natin dito, possibly, pwede gamitin natin dito is 62.427 pound of force per cubic feet. Pwede din naman 1,000 kilogram of force per cubic meter, or pwede din naman na 9.806 kilonewton per cubic meter. Pero for compatibility purposes, since ito is lahat in English units of measurement, ang gagamitin natin dito is 62.427. Ayan. So, mangyari ngayon dito is ganito. Ang gamma ng water para sa problem statement na to is equivalent to specific gravity ng H2O na given. Ang given niya is 0.9803 multiplied by the standard unit weight ng water. So, 62.427 pound of force per cubic feet. Tapos, ang specific gravity is 0.9803. Yan. So, gamma ng water na gagamitin natin for this particular problem is equivalent to what? So, kukompute ka lang muna, no? So, we have 0.9803 multiplied by 62.427. So, lumalabas sa kanya is you have what? 61.427 1972 pound of force per cubic feet. Ayan. So, ang gagamitin natin gamma ng water for specifically for this particular problem is 61.1972 pound of force per cubic feet. So, list down pa natin yung mga other given conditions natin. So, in suction and then discharge pressure, ang suction pressure natin 4 inches na mercury, and discharge pressure is 25 psi. So, P1, 4 inches na mercury, again, in units of the vacuum. So, since vacuum siya, negative P1. Ang P2 natin, referring to the discharge pressure, you have 25 psi. Ayan. So, gawin natin dito. Convert na natin yung value ng inches of mercury in terms of what? PSI. So again, magre-refer tayo sa standard reference for atmospheric or barometric. So you have 14.696 PSI all over 29.92 inches of mercury. Ayan. So 4 multiplied by 14.696 divided by 29.92. So, yung value ngayon natin dito ng P1, so negative P1 is equivalent to 1.965 PSI. So, other given conditions, sabi, ang discharge yung point kung saan nilalabas ng pump yung pinaka-water. So, discharge is, we're referring to what? Conditions sub 2. So, yung discharge elevation, so binabato niya 2 feet away from the pump center line. So, sabihin, kung meron tayong pump, yung pump na to, nasa baba, tapos susukat tayo na at least 2 feet mula sa baba o mula doon sa center line ng pinaka-pump, pataas, doon na ngayon din i-discharge yung pump na yan. So, malamalabas na yung Z2 natin, you have what? 2 feet. Tapos, ang pump efficiency natin, is you have what? 75%. Ayan. So, ito na ngayon yung mga listed conditions natin. So, ang gagawin natin dito is for us to be able to, again, determine the so-called, ano yung hinahanap? Ang hinahanap natin is what is the motor output. So, gawa tayo ng diagram or illustration. So, again, gagawa tayo ng diagram or illustration. Motor output. So, kung ito man yung tinutukoy nating electric motor, so, merong mapasok, input, merong lalabas. So, you have the so-called output. So, again, basahin ko ulit. What is the motor output? Ang motor output, kung titignan natin, base dito, no? Ang input natin dito is basically yung tinutukoy nating motor size. Tapos yung output natin is basically yung tinutukoy nating brake power. So, ayan. So, tingnan natin nandito kung motor side ang pag-uusapan natin. Kung meron tayong motor efficiency, again, you have output all over input. Kung saan ang output natin is you have the so-called brake power all over the so-called motor size. Ayan. Or yung tinutukoy nating motor output o yung tinutukoy nating brake power is equivalent to the motor efficiency tapos water size. Yan. However, kung titingnan natin itong formula na to, hindi siya possible gamitin kasi nga wala siya dito sa mga stated given conditions. So in this case, ang gagawin natin is i-isolate naman din natin uli yung tinutukoy nating driven equipment, which is yung tinutukoy nating pump. Yan. So kung ito yung pump, may papasok, merong lalabas. So yung lumalabas sa kanya is what we call the water power. Tapos yung pumapasok naman sa kanya, yun yung nilalabas dito sa mismong pinaka-electric motor, which is what we call the brake power. So kung meron tayong pump, since yung output hindi siya equivalent sa input, meron tayong tinatawag na efficiency. So yung pump efficiency natin, again, you have output all over you have input. So ang output natin, you have the so-called water power all over the output, which is what we call the brake power. So in this case, para makuha natin yung tinutukoy nating brake power is equivalent to the so-called water power all over the pump efficiency. So kung titingnan natin ngayon, ang formula ng water power natin, gamma ng H2O, volume flow rate ng water, tapos total dynamic head all over the so-called pump efficiency. So kung ito pagbabasihan natin, more or less, meron tayong mga given conditions dito. So in this case, ito yung gagamitin nating formula. So where natin, no? Where the so-called total dynamic head, ang formula niya, you have the so-called P2 minus P1 all over gamma ng fluid. So in this case, ang hinandle of fluid is water, so gamma ng water. So B2 square minus B1 square all over 2GO plus Z2 minus Z1 plus frictional losses measured from 1 to 2. So check natin. So walang frictional losses. So 0 to. So in this case, lumalabas, meron tayong Z2, pero wala tayong Z1. So Z1 neglected or eliminated. So wala din naman tayong mga corresponding speeds dito. So kung wala tayong mga speeds dito, mawawala itong velocity head. So in this case, ang formula natin ng total dynamic head, you have P2 minus P1 all over gamma ng H2O. So again, kung titingnan natin ngayon nandito, ang P1 natin dito is negative. So lumalabas, yung P1 natin dito na negative, yung P2 minus P1, then becomes P2 minus negative P1 or P2 plus P1. Ayan. Tapos plus Z2. Is equivalent dun sa bali ng total dynamic head. Yan, no? Total dynamic head. So in this case, ang formula natin ng brake power, which is what we call the motor output, is equivalent to what? Gamma ng water, volume flow rate ng water, total dynamic head. So you have P2 plus P1 gamma ng water plus Z2 all over what? All over the so-called pump efficiency. So compute na natin. So list down lang natin. So unit weight ng water natin. So ang unit weight ng water natin base doon sa earlier computation natin is you have 61.1972 pound of force per cubic feet. So you have 61.1972 pound of force per cubic feet. Tapos, volume flow rate ng water natin, you have what? You have 150 gallon per minute. 150 gallon per minute. Ayan. Tapos, P2 plus P1. So, P2 natin, you have 25. Ang P1 naman natin is 4. So, 25 plus 4. So, 25 plus 4 unions of what? PSI. So, ang PSI natin, ang identity is pounds per square inch. Plus, so, gamma ng water, ang gamma ng water natin is you have 62.427 pound of force per cubic feet. So, nakahiwalay siya. Yan. So, pound of force. So, kinakala mo wala akong complete thesis square inch. So, provide tayo conversion. For every 12 inches, you have 1 feet. So, para mawala yung square inch, 12 square inch for every 1 square feet. So, square inch, cubic feet, saka square feet. So, may matitira ditong feet. Plus what? Plus Z2. So, kung titignan natin, ang Z2 natin is equivalent to what? 2 feet. So, 2 feet plus 2 feet. Ayan. Plus 2 feet. All over the so-called pump efficiency. Ang pump efficiency natin is 75%. So, you have 0.75. So, yung choices natin is horsepower. So, horsepower yung choices natin. So, tingnan natin mangyayari ngayon dito. So, yun nasa loob ng parenthesis natin dito. Ang ibibigay niyang unit is actually feet plus feet or unit of feet. So feet, pound force per minute. Tapos, meron tayong 33,000 feet-pound force per minute per 1 horsepower. So, in this case, kinakailangan mag-cancel out na lamang si gallon sa kasi cubic feet. So, po-provide tayong conversion. Si gallon nasa itaas, so si gallon nasa ilalim. So, for every 7.481 gallon, you have what? 1 cubic feet. So, in this case, cubic feet, gallon sa gallon. So, feet pound force per minute. So, sa pa natin conversion is for every 33,000 feet pound force per minute, you have 1 horsepower. So, feet pound force per minute, yan. Matitira is horsepower. Ayan. So, once computed, once computed, ang nilalabas sa value. So, pindutin lang muna natin, no? So, you have 29 plus 4 divided by 64 or 62.427 times 144. Meron pala akong mali na ilagay dito, no? So, P2 plus P1. So, yung P1 na ilagay ko dito is actually 4, whereas dapat ang malagay ko pala dito is, it should have been 1.965. So, burahin natin. 1.965 dapat. 1.965 plus 1.965. Ayan. So, pindutin natin, no? So, pakita lang din natin yung nasa calcu. So you have 25 plus 1.965 divided by 62.427 times 12 square plus 2. Yan. So itong part ng total dynamic head na to is equivalent to what? 64.2 multiplied by 150 multiplied by 61.1972. So sa numerator part, ito yung value niya divided by 0.75 divided by 7.481 divided by 33,000. So, ang dapat lumabas, ulitin ko ulit, no? So, you have 25 plus 1.965 times 112 square divided by 62.427 plus 2. Yan. Times 150 times 61.1972 divided by 0.75 divided by 7.481 divided by 33,000. So, lalabas is you have 3.183. So, ang ano natin dito, ang motor output which would serve as the brake power is equivalent to 3.183 horsepower. So, base dito sa mga choices natin, ang pinakamalapit is you have 3.24 horsepower, or yung choice natin is letter A. 3.24 horsepower. So, yung choice natin dito is letter A. Ayan. So, ang motor output which would serve as the brake power natin which would serve as the motor output, ito yung requirement ng problem natin. If properly tabulated is 3.183 horsepower, so almost equivalent to 3.24 horsepower. Yun yung choice natin which is listed at A. So, ayan. So, ito yung problem number 5. So, yung choice natin is A. So, ayan. So, problem number 6 na tayo, no? So, basahin ko. The discharge side or discharge pipe of a pump is 200 millimeters in diameter, where water is to be discharged at the rate of 0.5 cubic meter per second. Discharge pressure is maintained at 100 kilopascal, where the end of this pipe is to be located 32 meters above the pump center line. So, ang requirement dito is what power is needed to drive the pump. So, again, start tayo by listing down properly the given conditions. So, given. So, discharge. So, pag sinabi natin discharge, we're referring to sub 2 conditions. So, diameter. So, D2, you have 400 millimeters in terms of in diameter. So, volume flow rate natin. So, yung volume flow rate is constant para sa 1 saka sa 2. Volume flow rate ng water natin, you have 0.5 cubic meters per seconds. So, discharge pressure, you have P2. You have 100 kilopascal. Tapos, yung end of down ng pipe na to is to be located 32 meters above the pump center line. So, yung pinakadulo. So, pinakadulo, hindi start point. So, pag start point, we're referring to sub 1 conditions. So, end ng pipe natin is discharge condition. So, lumalabas yung elevation head niya para doon sa discharge. You have what? 32 meters. So, requirement dito is what power is needed to drive the said pump. So, again, gawa tayo dito ng diagram or illustration. So, kung ito man yung tinutukoy nating pump. So, pump to, no? Ito yung centrifugal pump. Meron papasok. In. Meron lalabas. You have out. So, kung ano man yung pumasok on the part of the pump, no? So, pumasok is what we call the brake power. Tapos, kung ano man yung lumabas is the so-called water power. So, ayan. So, kung titignan natin ngayon yung nandito, so, kung titignan natin yung nandito, no? Pump efficiency is you have, again, output all over input. So, output natin, you have the so-called water power all over what? All over the so-called brake power. So, yung magpapandar do sa pump. So, yung papandar sa pump is yung input, hindi yung output. Ito yung tinutukoy nating brake power. Ayan. However, ang problem natin dito is, again, wala tayong pump efficiency. So, for us to be able to solve for the power needed to drive the pump, kinakailangan natin ng brake power. Pero kung titignan natin, hindi pumasok sa brake power, lalabas siya sa water power. So, technically speaking, pwede na rin natin consider as the water power, yung requirement natin. So, power required to drive the pump, consider natin siya as the water power. In the absence of pump efficiency. Ayan. So, ano formula natin ng water power? So, formula natin ng water power, you have gamma ng H2O, volume flow rate ng water, tapos total dynamic head. So, in this case, wala naman tumutukoy na condition kung saan pagkukuha na natin siya ng gamma ng water. So, in that case, pwede na natin gamitin yung standard unit weight ng water. So, since SI naman yun nandito, ang gagamitin natin dito is 9.806 kN per cubic meter. Volume flow rate natin dito is at 0.5 cubic meter per second. So, breakdown na lang natin. Specify natin yung total dynamic head. So, total dynamic head is composed of the so-called pressure head, P2 minus P1, all over gamma ng fluid. In this case, again, gamma ng water, plus B2 square minus B1 square all over 2GO plus what? Plus Z2 minus Z1 plus HF1 and 2. So, ayan. So, check natin. So, wala namang frictional losses. Again, so this part is considered to be negligible or neglected. So, ito, wala. Pero ito, meron siya. So, P2, P1, meron lang tayo dito is P2. So, in the absence of P1, tanggalin natin siya. So, P2 all over gamma ng water. So, in this case, na natin, siya saan po gagamitin yung diameter. So, yung diameter, pwede natin pagkuhanan ng speed or velocity. So, kung titignan natin dito, lumalabas, meron tayong discharge diameter ng pipe na nakakonekta dito sa mismong pinaka-pump itself. So, in this case, yung D2, pwede natin pagkuhanin ng speed at 2. Pero kung given yung diameter ng intake side ng pinaka-pipe, pwede natin pagkuhanin ng speed at 1. So, in that case, since wala naman tayong D1, diameter ng pipe para doon sa pinaka-point of intake, nineglect na lang natin siya. So, ayan. So, lumalabas, ang formula natin ng total dynamic head then becomes what? P2 gamma ng water plus B2 square all over 2GO plus Z2. So, titignan natin properly, meron tayong Z2. So, meron tayong P2. Meron tayong standard gamma ng water. So, meron tayong standard value na observed gravity. So, wala tayo so far is yung tinutukoy nating speed or what we call velocity. So, tingnan natin. So, lagay natin volume flow rate, which is represented by this one, is you have what? Volume per unit time. Yan. Or, as a pang formula nito, is you have what? Area multiplied by velocity. Yan. So, check natin kung parehas lang. So, area, possible unit ng area, you have square meter. Speed or what we call velocity, you have meter per seconds. So, in this case, square meter sa meter combined would eventually yield to a unit of the cubic meter per seconds. So, ayan. So, check natin, no? So, volume flow rate, ang typical formula is you have volume per unit time. However, meron pa tayong approximate formula. So, you have area multiplied by the so-called velocity. So, to prove unit ng area, possible unit ng area, you have square meter. Possible unit ng speed or what we call velocity, you have distance in terms of meter per unit time in terms of second. So, if combined, a square meter sa meter combined would eventually turn into cubic meter. Cubic meter per second, possible unit ng volume flow rate. So, ayan. Now, to obtain yung value na tinutukoy natin, kunin na natin yung velocity. So, speed or velocity at discharge. So, b square to. Okay, ito yan na. So, formula yung gagamitin natin is you have volume flow rate, you have area, then velocity. So, ang pipe natin has a circular cross-section. So, lumalabas 5 all over 4. Diameter ng pipe natin, square. Tapos, speed or velocity. Ayan. Or, simplify pa natin further, 5 all over 4 d2 square tapos b2. So, ayan. So, for us to be able to solve for the value of the speed or velocity, lumalabas b2, therefore is equivalent to 4 volume flow rate all over 5 diameter 2 square. So, check natin. So, you have 4. Ang value natin ng volume flow rate is 0.5. So, you have 0.5 cubic meter per seconds all over 5. Diameter natin, ang diameter is 400 millimeters. So, you have 400 square millimeter. Convert natin for every 1 meter. You have 1,000 millimeter. So, distribute natin power of 2, power of 2, power of 2. So, mangyari, kakancel out yung square meter, meter cube, saka meter, may matitirang meter. So, meter per second, possible unit ng speed or velocity at the point of discharge. So, B2 natin. So, you have what? 4 multiplied by 1, 3 square times 0.5 divided by 5 divided by 400 square. So, you have 3.979. So, speed natin at the point of discharge is you have 3.979 meter per seconds. So, ayan. Yan, no? So, ito siya. Now, to solve finally for the final requirement, ang gagawin natin dito, formula, water power, gamma ng water, volume flow rate ng water, then total dynamic head. So lalabas is ito. Water power, gamma ng H2O, volume flow rate ng water, total dynamic head. Gamma ng water once again, volume flow rate ng water, total dynamic head. Ang total dynamic head natin, you have P2, gamma ng water once again, plus B2 square all over 2GO plus Z2. Yan. So, computein na natin. So, gamma ng water, so, gamitin natin yung standard. Ito, no? So, ang gamma ng water, tatlo. So, pero dalawang pwede natin gamitin para wala masyadong conversion. Either 1,000 or 9.806 kilonewton. 1,000 or 9.806. So, para less yung conversion natin, at ang choice kasi natin dito is kilowatt, ang gagamitin ko is 9.806. 9.806 kilonewton per cubic meter. Ang unit, ang volume flow rate ng water natin is 0.5 cubic meter per second. 0.5 cubic meter per seconds. Yan. Tapos, ang P2 natin is 100 kilopascal. So, P2, 100 kilopascal. Identity ng kilopascal is kilonewton per square meter. So, gamma ng water na gagamitin natin is 9.806 kilonewton per cubic meter plus B2. Ang recently computed value niya, you have 3.979 square meter per square second all over 2. Ang standard gravity natin, 9.806 meters per second square. Yan. Plus Z2. Ang Z2 natin is you have 32 meters. Yan. So, kung check natin yung solution, yung total dynamic head natin dito, itong part na to should be expressed in terms of the meter. So, kilonewton, cancel out, cubic meter sa square meter, meter. So, meter square, second square, meter all over second square, meter. So, meter plus meter is unit of the meter. So, check natin. So, computein natin yung value. So, you have 100 divided by 9.806 plus 3.979 square divided by 2 divided by 9.806 plus 32. So, yung total dynamic head natin dito, specifically for this particular portion, is equivalent to 43.005. Multiply natin sa 0.5. Multiply natin sa 9.806. So, technically, ang value lalabas should be equivalent to 210.854. So, water power natin is 210.854 kilonewton meter per seconds. So, yung kilonewton meter is kilojoule. Kilojoule per second is what we call kilowatt. So, ang pinakamalapit is you have 211. Ang choice natin is A. 211 kilowatt. Yan. So, ang choice natin for this particular problem is 211 kilowatt. Yan. Ito siya. So, ito, no? So, this is for problem number 6. So, meron pa tayong isang problem. So, last problem natin is problem number 7. So, yung choice natin dito is for A. So, yung last problem natin is actually problem number 7. So, ito. So, problem number 7. Sagutan natin. So water from an open reservoir located 5 meters above the pump center line is pumped into a tank 85 meters above the pump center line. Discharge is made through a 900 mm diameter cast iron pipe at a pressure of 1 kg force per square centimeter. So this pump has a positive suction head of 5 meters and then a pump rate of 1.5 cubic meter per second. If the frictional losses amount to 3 meters, what is the power output of the pump? So gawan muna natin ng illustration yung problem natin. So para mas maintindihan, so gawan natin illustration niya na. Illustration. So gawin natin yung illustration ng ating problem statement. So ito yung pump natin. Ito yung piping natin. So list down natin mga given conditions. So water from an open reservoir located 5 meters above the pump center line. So yung pinaggagalingan natin ng source, yung pinaka-source natin is located above the pump center line. So 5 meters. So tayo mula dito ng 5 meters. Ayan. So discharge daw to 85 meters above the pump center line. 85 meters. Ayan. So, yung pinaka natin, So, yung pinaka Z1 natin, yung source. So, basta source intake, sub 1 condition, yung discharge sub 2 condition. So Z1 elevation is measured 5 meters above the pump center line. Yung Z2 naman natin, you have 85 meters. So kung nagkataon lamang na yung source natin is located below the pump center line, ang Z1 natin is negative. However, in this case, since yung pinaka-source natin is located above the pump center line, ang Z1 natin is actually considered to be positive. So, pagdating din sa formula natin, yung original formula natin na Z2 minus Z1, mariretain natin siya. So, kung nagkataon lamang na yung source natin is located 5 meters below the pump center line, yung Z2 minus Z1 then becomes Z2 minus negative Z1. So, magiging Z2 plus Z1. So, in this case, mariretain lang natin yung formula. So far, meron tayong 5 meters, meron tayong 85 meters. So, yung discharge daw, pinaglalabasan niya is yung diameter ng pipe natin, D2, is equivalent to 900 millimeters. Tapos, ang discharge pressure daw dito, ang discharge pressure is what? 1 kg force per square centimeter. So, P2, 1 kilogram of force per square centimeter. So, para mas madali natin siyang gamitin, convert na natin siya. So, ano yung conversion natin? So, convert natin itong P2 na kilogram force per square centimeters in terms of the kilopascal. So, ang gagamitin natin ditong reference is yung standard reference for atmospheric or barometric. So, kukuha tayo ng sample ng hangin sa atmosphere. May mga corresponding numbers yan. So, iba-iba na numbers, pero iba-iba din ang corresponding units. So, 101.325 kilopascal for every 1.0332 kilogram of force per square centimeter. So, ayan. So, cancel out. So, yung P2 natin then becomes what? 98.069 kilopascal. Another one to point out is ito. Sabi, water from an open reservoir. So, kung open, talagay natin dito, subjected to atmospheric pressure. So kung subjected to atmospheric pressure, ang gagamitin natin value 101.325 kilopascal. So malabas, ang P1 natin dito, ito is open, di ba? So kung open, meron tayong tinatawag na atmospheric pressure. So yung P1, kasi point of entry, point of suction, you have 101.325 kilopascal. Ayan. So other given conditions, list down natin properly, no? Meron tayong 1 kg force per square centimeter. Meron daw siyang positive suction head of 5 meters. So yung tutukoy niyang positive suction head, basically is ito rin siya. So kung nagkataon lamang na yung source natin is located below the pump center line, hindi positive suction head ang tawag sa kanya. Rather, ang tawag sa kanya is negative suction head. So since yung number nito basically is ito rin siya. So dinescribe lang siya dito. So okay na rin tong 5 meters natin. So sunod natin dito is yung pump rate. So pump rate natin is 1.5 cubic meter per second. So volume flow rate ng water natin, you have 1.5 cubic meter per seconds. Ayan. So if the frictional losses, so given first time around, no? So given yung friction losses, HF1 to 2, you have 3 meters. Ang sawag dito is what is the power output of the pump. So magdodraw tayo ulit ng isang pump natin. So magdodraw tayo ulit dito ng isang pump. Supposedly ito yung pump natin, label natin pump. So meron papasok, meron lalabas. Output ang pinag-uusapan natin. So basically, ang hinahanap natin dito is yung water power. Sa input kasi, ang tawag natin is the brake power. So, water power is the output of the pump. Yan. So, water power basically is gamma ng water, volume flow rate ng water, tapos total dynamic head. Ayan. Total dynamic head. So, check lang natin. So, wala tayong problem dito sa volume flow rate ng water, gamma ng water. So specify na lang natin yung tinutukoy natin total dynamic head. So formula natin total dynamic head. Total dynamic head is equivalent to what? P2 minus P1 gamma ng H2O B2 square minus B1 square all over 2GO plus Z2 minus Z1 plus frictional losses measured from 1 to 2. So in this case, given yung frictional losses, so meron to. So given yung diameter do sa pinaka point of discharge, so again, meron tayong makukuha doong speed. However, since wala tayong diameter doon sa may pinaka suction side na pinaka pump, so yung initial speed or initial velocity is found to be 0. So given parehas si Z2 as well as si Z1. So in this case, although walang statement na meron tayong P1, meron tayong suction pressure, pero since open naman yung pinaka source natin to the atmosphere, so kung open siya, it is subjected to what we call atmospheric pressure. So in this case, yung P1 natin atmospheric, so 101.325. So yung P2 naman natin is given at 1 kg force per square centimeter, so 98.069. So in this case, ang P2 minus P1, since mas mataas yung value ng P1 natin as compared sa P2, lumalabas, itong portion natin dito is said to be negative. So first time na nangyari na lumabas na pag ginawa natin difference, instead na positive, ang lalabas sa kanya is negative. So ayan, meron siya. So tuloy pa natin further. So gawin natin dito is hanapin natin yung pinaka-speed or velocity. So again, volume flow rate at 2 from volume flow rate formula, area, velocity, phi all over 4 diameter square velocity. So in this case, para makuha natin yung speed dito, so lalabas natin dito is ito, volume flow rate phi all over 4 diameter sub 2 square B2. So B2 therefore is equivalent to 4 volume flow rate phi diameter square diameter 2 square. So 4, so lalabas 1.5 cubic meters per second. Phi diameter natin is 900 millimeters. So 900 square millimeter per every 1 meter, meron tayong 1,000 millimeter. 1,000 millimeter. So distribute natin power of 2, 2, saka 2, 2. So, kakancel out si square millimeter. Square to square. Yan. So, mababawasan si cubic meter. Mawawala si square meter. So, meter to, meter per second. So, if properly computed, ang bali natin dito, ng speed or velocity at the point of discharge, you have 4 multiplied by 1.5 multiplied by 1,000 cube square divided by shift phi divided by 900 square. So you have 2.357. So 2.357 or 2.358. So ang speed natin B2, yeah, 2.358 meters per second. Ayan. 2.358 meter per second. So, ayan. So, ang mangyayari ngayon dito is actually ganito. Since meron na tayo ngayon ditong B2, pwede na natin gawin yung total dynamic head. So, total dynamic head, you have TDH formula, you have P2 minus P1 all over standard unit weight ng water plus B2 square all over 2GO plus Z2 minus Z1 plus frictional head losses sa point of entry sa point of discharge. So, ayan. So, lumalabas na yung P2 natin, ang P2 natin is 98.069. So, 98.069 minus, so sa number 1 nakalagay dito is from an open reservoir. So since wala naman sinasabi dito na siya is actually in vacuum, lumalabas hindi siya maging minus negative B1. So lumalabas minus atmospheric pressure value which is 101.325. 101.325. So unit niya kilonewton per square meter all over standard unit weight ng water 9.806 kilonewton per cubic meter. Yung B2 natin, ang B2 natin is you have 2.358 square meter per square second all over 2. A standard acceleration due to gravity o standard gravity natin, you have 9.806 meter per second square. So yan. Plus Z2. Ang Z2 natin is 85. Tapos ang Z1 natin is positive. So instead na Z2 minus negative Z1, since it is positive suction head, so you have still Z2 minus Z1. So you have 85 minus 5 in units of what? Meter. Plus frictional losses. Ang frictional losses natin is 3 meters. Yan. So frictional losses natin is 3 meters. So ito siya, no? So lalabas, check natin. So dapat total dynamic head, ang lumabas dito unit should be expressed in terms of meters, which is M. So kilonewton, square meter sa cubic meter, meter. Square meter, meter, for second. So meter. Meter plus meter plus meter plus meter is unit of the meter, which is a unit that is used to represent units of the total dynamic head. So check natin. So you have here what? 98.069 minus 101.325 by 9.806 plus 2.358 square divided by 2 divided by 9.806. Yan. Minus 80 plus 80 plus 3. So, lumalabas na yung ating total dynamic head. Ang total dynamic head natin for this particular part is you have 82.951 meters. So, ito. 82.951 meters. So, ito siya. Ito siya, no? 82.951 meters. So, check natin. Kuhanin na natin yung tinutukoy nating water power. So, formula natin water power is basically ito. Ulitin lang natin. So, water power, therefore is equivalent to gamma ng water. Standard unit weight ng water, 9.806 kilonewton per cubic meter. Ang volume flow rate ng water natin, 1.5 cubic meter per seconds. 1.5 cubic meters per second. Tapos, you have 82.951 meters. So, magka-cancel out sa cubic meter. So, ang pump output natin, ilagay ko, pump output natin, which is basically considered to be the water power, is equivalent to 82.951 times 9.806 times 1.5. So you have 1,220. So you have 1,220.13. 1,220.13 kilowatt, which is almost basically equivalent to, sa mas malapit yung 1,220. So mas malapit siya sa 1,234. 1,234 kilowatts. So, in choice that is C. And so, yung pinaka-pump output natin is equivalent to 1,234 kilowatts. So, yun ang conclude sa discussion natin. So, I have cited 7 problems. So, hopefully, naintindihan yung pinaka-concept. So, thank you and goodbye.